Welcome back. Today in 11.3, we're going to continue our practice of completing the square in order to create the vertex form, which means we can steal the vertex from the equation and then we can graph. So what we're going to do today is our first thing should say, I will be able to find values to complete the square and then use completing the square to find the vertex. You will then actually graph the quadratic function. So here's a quick review of what we just did in 11.2. The first thing you need to do is add or subtract the C term, the constant, to the other side, the left side. And then that will leave spaces. We will have, for example, we might have 2x squared plus 4x and then plus. You're leaving that empty space, just like we practiced yesterday. We need to find the value that completes the perfect square and add it to both sides of the equation. Once you have that, we factor the right side and simplify the left. We will then go and add or subtract the constant back over to the right side. These steps should sound awfully familiar because we just did them. Once we have done that, step 5 says we set it equal to 0. This is what we practiced in 10.2, where we set the factors equal to 0. Now in step 6, something's going to happen where we're going to have to undo a square. What I need you to think about when we talk about undoing the square, we talk about the opposite of adding is subtracting, the opposite of multiplying is dividing. What we may or may not have told you is that the opposite of a square, like let's say 4 squared, the opposite of square is a square root. So if we take 4 and we squared it, we get 16. The way I go backwards to get back to my 4 is I take my 16 and I undo the square, I take the square root. The square root of 16 is 4. So one new thing today is the opposite of a square. Make sure we get this. The opposite of a square is a square root sign. Anytime you take the square root in an equation, you must make the square root a positive and a negative. And the fancy way we write it is the positive right over the negative sign. And you will see what that looks like in just a minute when we practice it. Once we're done, we will create the two different cases. We'll do one plus it and then one minus it. And then we will find our answers. I'm going to ask for both decimal form and radical form. And you'll see what I mean as soon as we start practicing. So here's our first example. We have x minus 5 squared minus 8. This is already in vertex form. So we can actually steal the vertex to start graphing. The vertex is located at positive 5, negative 8. So if we would like to visualize that, that's positive 5, negative 8. So there's the vertex of my graph. Now, if I would like to find the x-intercepts, we need to go ahead and solve that equation. So here's what we're going to do. I'm going to write it so we can see it. We're going to change the y to a 0 because remember now we're solving. We wanted to say 0 equals. I'm going to move the constant, the minus 8, I'm going to do the opposite and do plus 8. So now I have 8 equals x minus 5 squared. Well, I'd really like to find out what x equals so I can find my x-intercept, but I need to get rid of the square. The opposite of a square is a square root. So what you're going to do is take the square root of both sides, because whatever you do to one side, you must do to the other. When you undo a square, that means the x minus 5 is now free. We basically got rid of the square by taking the square root. It undid it. And then I have the square root of 8. Now remember, that can be simplified. That could be 4 times 2, which is 2 times 2. There's a pair of 2's. So a 2 comes out, and the 1, 2 stays in. And that is equal to the x minus 5. So all I have to do now, I'm going to rewrite this exact line right here just so we have room. I have 2 square root of 2 equals x minus 5. I am super close to my x being by itself. The only thing that is next to the x to keep it from being alone is that minus 5. So I'm going to add 5 to both sides. Now my x is alone, but you'll notice those are not like terms. 2 radical 2 and 5 are not like terms. They are both not radicals. So we cannot write them together. So we're going to write it as 5 plus or minus 2 radical 2. The step I skipped when we did the radical, I forgot to put our plus and minus sign right over there. So make sure you add that. So the radical answer is our x-intercepts can be found using 5 plus 2 radical 2, or it could be 5 minus 2 radical 2. And this is where you would want to get your calculators out. If we go into our calculators and we type in 2 radical 2, so I am typing into my calculator right now, 2 times radical 2, and I get a decimal answer of about 2.8. So I'll have 5 plus, we'll round to 2.8, would be 7.8. So one of our x-intercepts is at 7.8. If we do the same thing and we do 5 minus 2.8, we will get 2.2. That is our other x-intercept. So if I go to graph now, I'm at 7.8 on the x-axis, and I'm also going to be at 2.2, just a little more than 2. If I wanted to just kind of sketch and get an idea using the 1:3:5 ratio that we learned last unit, we're going to rise 1, run 1, rise 3, run 1, rise 5, run 1. And then we can go the other way and kind of get an idea of what our parabola should look like. There we go. Take a moment, take that in. That's a lot of work. That's probably the first time you've taken the square root of a square. And the more we practice, I promise, the better you will get. So let's practice another one. Here we go. Right now, this one is not in vertex form, so the first thing we want to do is write it in vertex form. That's why we learned this in the beginning of the unit. First thing we're going to do is set it equal to 0 instead of y, so we can solve it. And now we're going to subtract that 1. 0 minus 1 is negative 1, equals x squared plus 4x, and we created this space because we're going to come up with that magic number. We're going to take that 4, cut it in half, and then square it. Ooh, we're right back to 4. And remember, whatever you do to one side, you do to the other. So now we have negative 1 plus 4 is 3, is equal to x squared plus 4x plus 4. When we go to factor that, that's going to become x plus 2 times x plus 2. If you're not sure how I did that, I found two numbers that multiply to 4 that also add to 4. And remember, earlier in the notes, we said, remember, it is always half of b. Well, since b was 4, that means the thing that's going to duplicate is half of the 4, which is 2. And because there was 2 of them, I write it once, but say that it is squared. The only thing I have left is to move that 3 back over to the other side. So we're going to subtract it over. So now we have 0 is equal to x plus 2 squared minus 3. So vertex form is exactly what we just wrote. X plus 2 squared minus 3. We can steal a vertex by doing the opposite of positive 2 and keeping the negative 3. Because the x squared is positive, the parabola opens up. Because it opens up, that means it is a minimum. The y-intercept is the constant on the end, the 1. Now here's where our real work comes in. We have to find our x-intercepts. So let's go ahead and solve that equation. I'm going to take the one that we just wrote. I'm going to do a little bit of erasing right here just so I have some room. We wrote 0 equals x plus 2 squared minus 3. I'm going to add that 3 back over, So I have 3 equals x plus 2 squared. The opposite of square is square root, so I'm going to take the square root of both sides. So now I have x plus 2 is equal to a positive or a negative radical 3. The only step left to get x by itself is to move this plus 2 over. So now I have negative 2 plus or minus the square root of 3. If I go into my calculator and I type in the square root of 3, I will get that it's about 1.7. So the two x-intercepts can be found by doing negative 2 plus 1.7 and negative 2 minus 1.7. I'm taking this statement right here and I'm breaking it into the plus sign and the minus sign. So negative 2 plus 1.7 is a negative 0.3, so that is one of my x-intercepts. Negative 2 minus 1.7 is negative 3.7, so that is my other x-intercept. So let's graph those points that we found. The vertex is at negative 2, negative 3. The x-intercepts are at a negative third and a negative 3.7, roughly there, a little off. And if we follow our rise 1, run 1, rise 3, run 1, rise 5, run 1, we can get our mirror image points. And we do know from here that the y-intercept is at positive 1, and that looks right where we're going to intersect. And we are able to graph. Now that is a lot of math. That tells you we are definitely near the end of our Algebra 1 curriculum. When we can take a quadratic equation, set it equal to 0, we can complete the square to come up with this equation, which we can then solve by taking the square root, and then we break that into two statements to get our final two x-intercepts. That's about as rough as the completing the square in vertex form is going to get. So if that's feeling kind of rough, that's okay. We will definitely be spending more than a day or two in class practicing. But hold on, let's just practice another one and see if we feel any better. So here we go. Remember, we're going to set it equal to 0. We're going to bring that positive 11 over as a negative 11. So we have negative 11 equals x squared minus 6x plus some perfect square number. I'm going to take my negative 6, cut it in half, that's negative 3. Negative 3 squared is 9. So the magic number I'm going to add to both sides is a positive 9. That leaves me with negative 2 equals x squared minus 6x plus 9. The whole reason we chose this magic 9 was because when I go to factor now, I know that whatever number goes inside these parentheses, it's the exact same number. And the hint is we go half of this negative 6, which is negative 3. So the negative 3 duplicates. That is the number that multiplies to 9 that also adds to negative 6. It is negative 3 and negative 3. So because it is the exact same thing, we get to write it only once, but say that we have two of them. So now let's go ahead and solve it. We're looking really good. To find our vertex form, we would add the 2 back over. So now we have 0 equals x minus 3 squared plus 2. So to steal the vertex, I do the opposite of negative 3, which is positive 3, and then the 2 stays the same. The x squared is positive, which means it opens up. Oops, meant to write the word up. Because it opens up, that means the vertex is a minimum. It's the lowest the graph goes. The y-intercept is the constant on the end. It is the 11. The only thing we have left to fill out is our x-intercept. That's where we're going to take that last part of the equation we were at, we are at negative 2 equals the x minus 3 squared. So I'm going back to before we added the 2 to the other side. There we go. So the undoing of the square is square root. Ooh, can we take the square root of a negative number? Is there any number times itself that will ever equal a negative number? If you have never thought about it, the answer is no. There is no number times itself that could ever equal a negative number, because a negative times a negative is a positive. So there is no number times itself that could possibly equal a negative number. The nice thing when this happens, that means there is no solution. There is no way to finish solving it, which simply means there's no x-intercept. So when we go ahead and plot the vertex at 3, 2, and if we rise 1, run 1, rise 3, run 1, rise 5, run 1, we will see that this graph will never ever cut through the x-axis. That's why there is no solution. There is no x-intercept. So how are you feeling with completing the square and then solving it, and then being able to see whether or not it has x-intercepts? If you are feeling okay that you can follow that process, then you are definitely done and ready to get your assignment when you're in class. If you would like to rewatch, this is definitely one of the most intricate lessons we've done all year. I would recommend rewatching the video without writing anything and just watching and listening. If you feel you can complete the square to find the vertex form and graph and you feel comfortable, then you are good.